Hello and welcome to Oregon State University's Farm to Fork webinar series. My name is Sherry Cole. I'm the director of OSU's Sustainable Food Manufacturing Program, and I'll be your moderator for today. First, we want to thank you for taking the time to join us. We know that you have a lot that competes for your time and attention, and we really appreciate you joining us. Our intention with the Farm to Fork series is really to expand the conversation about how our food systems work, and importantly, how they're changing and changing for the better to become more sustainable and resilient, but also for the people who are helping to create that change. So before I introduce today's presentation, I just want to briefly talk about some logistics. First, we're recording the webinar. We want to make this available to others who couldn't join us today. And so at the next week, that'll be on our website, and we welcome you sharing that with others. Also, we really do want this to be as much of a conversation as it can be. And so we've reserved the last 15 minutes of the webinar for your questions. So you see at the bottom of your screen, the Q&A feature. Please click on that, add your questions over the course of the presentation, and I'll prompt you at the end as well, because we really do want to hear from you. You also have the opportunity to upvote a question. So if you see another question in the queue that you like, upvote that, and then that'll rise to the top of the queue. So with that, it's my pleasure to introduce today's presentation, Reducing Waste in Food Packaging, the current programs at Oregon's Department of Environmental Quality.
All right, good afternoon. Can you hear me okay? Yes, perfect. Thank you so much. Okay, let me just get my screen sharing going here. And here we go. All right. Okay, well, good afternoon again, and thank you, Sherry, for the invitation to speak. Oregon DEQ is the state's agency charged with protecting and restoring Oregon's environment. And we approach this work using a variety of methods and programs. One of those programs, materials management, is the program that I work in, and it is charged with reducing the environmental and human health impacts of materials across their full life cycle. Today, I'm going to share some work that DEQ's materials management program is conducting that intersects with food systems via three distinct topics: food waste and loss, packaging design, and package recycling. Reducing food waste is a very high priority for DEQ and has been for several years now. Why? Because first of all, we waste a lot of food, not DEQ by itself. The country wastes a lot of food. It's estimated that as much as 40% of all food grown or imported into the United States is wasted. That's a staggering amount of loss. Importantly, that wasted food represents a tremendous loss of resources. If all the food wasted in the US was grown on one farm, it would occupy an area 3/4 of the size of California. All of the water currently used in Texas, California, and Ohio combined would be needed to grow that food. And this doesn't include other impacts such as energy and fertilizer and pesticide production and use. Food is also a very high impact material when it comes to climate change. If people think at all about the climate impacts of food waste, most of the time they think of the methane generated when food decomposes in landfills. And this graph shows the climate impact per ton of managing wasted food. Landfill impacts on the left are pretty high at about 1/2 ton of carbon dioxide equivalent for every ton of food sent to landfill on average. We can eliminate those impacts and gain some benefits through anaerobic digestion and composting. But look at the greenhouse gas reduction potential if we prevent waste in the first place. It's 6 to 7 times greater per ton than digestion or composting is. The reason that prevention has so much more potential is that the vast majority of environmental impacts from food come during production, not disposal. And this graph illustrates that point. It shows the greenhouse gases generated by consumption by Oregonians in 2015. You can see that food is our second largest category of these consumption-based greenhouse gas emissions, second only to vehicles. If you take a close look at the food bar, which is color-coded, it shows where those greenhouse gas emissions occur, and you can quickly see that almost all of them happen in the production phase. A very small amount is associated with disposal of food waste in landfills. For every pound of food we waste, we're wasting all of the resources that went into producing it in the first place. And so because of these upstream impacts of food production, DEQ emphasizes prevention or source reduction, as you see here at the top of a wasted food policy hierarchy, followed by donation of surplus food to feed food insecure people, and then industrial uses, anaerobic digestion, and composting. Sometimes those are flipped. Almost every environmental policy organization subscribes to some version of this hierarchy, but for the most part, actual policy approaches to food waste don't focus on the top of the hierarchy. Most attention is still paid to keeping food waste out of landfills through composting and digestion. One reason for this might be that we all think food waste is mainly stuff we wouldn't eat, like shells and peels and bones. But it turns out that that's not the case. DEQ's own recent research, a combination of waste sorting and household diary studies, has shown that of all the food wasted by Oregon households, nearly 70% was food that could have been eaten if it hadn't been left to spoil. Only 30% was made up of inedible components. So what this means is that there's a very big potential opportunity in prevention. That 70% is what we really want to go after. Another thing that people commonly believe when they think about excess food is that we just need to collect and redistribute it all to people who are food insecure. And that's not a bad thing, but it's also not practical. This illustration comes from data recently published by the US EPA. The whole loaf represents the calories in all of the edible food available in the United States, so it does not include inedible parts. Let's look at the portion of the loaf that is marked as surplus. You can see in the lower portion of the diagram that we only need about 1/4 of the calories in our surplus food to meet all the needs of food insecure populations in this country. So yes, absolutely, we should feed hungry people with our excess food, but doing so will not solve the problem of waste and loss. In 2020, Governor Brown issued her executive order on climate, and among other things, it directs DEQ to reduce food waste by half by 2030. Working with other states, local governments, and industry, DEQ is working to scale up our efforts at food waste prevention through several projects, and I'll just highlight a few of these in the next few minutes. First, let's look at efforts targeting households. It's estimated that just under half of food waste is generated by households. And one thing we learned in our research is that many people in Oregon think that this food waste is inevitable. But again, it is not. Remember that 70%. At DEQ, we wondered how we might motivate people in Oregon to reduce waste. And after fairly robust research, including a statewide survey, in October of last year, we launched an award-winning Bad Apple campaign. Our research told us that people in Oregon felt most motivated to reduce food waste by their dislike of wasting money. And this is a stronger motivator than environmental concerns. The research also told us that people believe they were already doing some basic things to reduce waste, such as making shopping lists and checking the fridge before shopping. But they also thought they could do more if they were told about simple steps they could take. So the Bad Apple campaign emphasizes how much food waste costs Oregon families and shows some simple steps they can take to reduce food spoilage at home. It uses humor to engage people and is running on a variety of broadcast TV channels and in social media. And we'll show here a quick 30-second spot that shows how to store broccoli to make it last longer to give you an idea of what the campaign's all about.
Don't let good food go bad. Your broccoli likes some moisture and cold air. So wrap it in a damp paper towel and refrigerate it in an open container to keep it at its best.
I'll take that. Hey, I'm a bad apple, and I can cost you real money. Spoiled food like me costs each household here in Oregon over $1,600 a year on average.
Learn more about simple steps that can reduce spoilage and save you real money at don'tletgoodfoodgobad.org.
Thank you for that. And let me get the screen back up. Good. Okay. All right, so we're also putting a lot of effort into the other half of food waste in our state, which is food waste generated by the commercial sector. Here, our emphasis is on coming up with ways to eliminate systemic and institutional contribution to food waste. The Pacific Coast Collaborative is an agreement among US West Coast states, the province of British Columbia, and the largest cities in those jurisdictions to work together to address climate change. And one initiative of the collaborative is the Pacific Coast Food Waste Commitment. It was formally launched in the fall of 2018. It aims to bring food businesses together in voluntary agreements to identify key contributors to food waste in their industries and to work together in a pre-competitive environment to mitigate those sources of waste. The project started with retail, and participating grocers include Kroger, Albertsons, Safeway, Walmart, and New Seasons, and other regional grocery chains. It expanded recently to add food processors and manufacturers with commitments from Food Northwest, as well as Bob's Red Mill and Organically Grown. And current plans include expanding further to the hospitality sector later this year. We already have informal commitments from 2 large hotel chains. After a COVID-related delay, the food commitment is launching pilot projects with grocers and manufacturers this year that include evaluating potential for e-commerce and improved technology to reduce grocery waste, repurposing bakery items for resale, and implementing innovative worker engagement programs to reduce waste in manufacturing. We're also doing some work with the Oregon Restaurant and Lodging Association, and now pivoting to producing some online materials and trainings in the form of brief, easy to digest videos. We plan to roll out some of this material in the next few months. And first up are some videos giving tips for reducing food waste in restaurant kitchens, and our video looking at ways restaurants can reduce food waste in the front of the house. So what's next? As we've worked more intensively on food waste prevention, we've come to realize that a more systems-based approach will allow us to think more expansively and creatively about food. We completed a survey of Oregon food systems in 2021, and that work has formed the foundation for a new strategic planning effort that we'll complete next year. Our hope is that we can explore ways we might engage that reduce and mitigate food waste while strengthening our food system. So let's change gears. This graph here is from a document on our website that explores the role of packaging in reducing food waste. And it summarizes hundreds of studies of carbon footprints of different types of foods, condensed for simplicity into a handful of categories. For most foods, you can see that the product is far more impactful than the packaging, at least when viewed through the lens of climate change. But regardless, there's a lot of public anxiety around the topic of packaging. Packaging impacts the environment in many different ways, again, both through its production as well as its disposal. There's a lot of concern about plastic packaging in the ocean. How does plastic from the United States get into the ocean? This recent research paper estimated 3 primary vectors shown here. Exports may be the largest contributor, up to 1 million metric tons in 2016. And these exports are, ironically, a result of a poorly regulated recycling system. Many recyclables in this country are collected mixed together. Households mix their paper, plastic, and metal into a single bin. And from there, the materials go to processing facilities that attempt to sort them out and produce bales of materials that can be sold into commodity markets. But that system is not working as well as it could. These photos were taken recently in East Java, Indonesia. A paper mill there purchased bales of waste paper from the United States, but those bales were heavily contaminated with plastic. The mill couldn't use the plastic and dumped it in the surrounding countryside. Now, the fact that our domestic landfills don't leak plastic waste into the environment, but the recycling system does leak plastic waste, is a nuance that is lost on many people. And so we see policymakers, consumer brands, and others suggesting that in order to solve the problem of plastic pollution, we need to make all packaging recyclable or compostable. If it were, then the problem you see on the screen here would be less of a problem, because the people in Indonesia could recycle or compost those plastics. But what about all the other environmental impacts of packaging, such as production? Does it make environmental sense to require everything to be recyclable or compostable? To answer that question, my office turned to an analytical technique called life cycle assessment, which is the quantification of environmental impacts across the life cycle of materials. Life cycle assessment estimates environmental impacts, such as kilograms of carbon dioxide equivalent or the depletion of fossil resources. These are the environmental impacts everyone wants to reduce. However, assessment of this form can be difficult and expensive, and the results can be counterintuitive and difficult to communicate. So instead, many businesses and consumers rely on some simple attributes, such as, is the packaging recyclable? Is it compostable? These attributes are commonly used as proxies for environmental goodness. It is assumed that if a material features one or more of these attributes, then it is inherently an eco-groovy choice. But is that assumption valid? To find out, we commissioned research that vacuumed up 17 years worth of published English language LCAs. We found thousands of comparisons in the literature. We dumped them all into a database, sorted them out, and here's just some highlights of what we found. This graph shows several hundred comparisons in the literature between a more recyclable package and a less recyclable but functionally equivalent alternative. The length of the green bars are the number of comparisons where the recyclable package had lower impacts. The length of the red bars are the number of comparisons where the recyclable package had higher impacts. That is, it's worse for the environment. Dark green and dark red are more significant differentials, and the yellow diamond is the net count of comparisons between them. So if recyclable packages are inherently better for the environment, we'd expect to see a lot of dark green and no dark red. But that's not what we found across hundreds of comparisons. What does this mean? Well, some recyclable packages are lower impact, as shown in green, and others are higher impact, as shown in red. But recyclability is a very poor predictor of environmental benefit. How about compostable packaging? Here are the results of several hundred other comparisons, and the basic pattern is the same. Some compostable items are lower impact, some are higher impact, and these differences rarely have anything to do with the composting process or the value of compost. Rather, they're a result of what materials are used and how they were manufactured. Bio-based materials show a similar lack of consistent benefit. Again, sometimes lower impact, sometimes higher impact, and this reflects variability in impacts of agricultural commodity production and the industrial processes that convert those commodities into packaging. This graph shows different packaging options with different levels of recycled content. For example, a glass bottle with 30% recycled glass versus a paperboard carton with no recycled content. In this comparison, recycled content also fails to correlate with environmental goodness or badness. The attribute is practically meaningless. But this next graph compares higher versus lower levels of recycled content for packages made of the same material. For example, a cardboard box, or a polystyrene clamshell, or a PET bottle, made with more recycled content versus the same material containing less recycled content. Again, several hundred comparisons in the literature, and here we find a consistent pattern. Once you've chosen your packaging material, increasing recycled content of that material is almost always found to lead to reductions in environmental impacts. So 3 key takeaways of the study. First of all, is that popular wisdom regarding packaging is very popular, but not consistently wise. A corollary is that attributes-based decision-making in packaging design is bound to lead to mixed environmental outcomes, not all of them good. What would be better would be to evaluate packaging materials for their actual impacts, disclose those impacts, and make decisions accordingly. And the third takeaway is that increasing recycled content can reduce impacts, but industries often find it difficult to increase their use of recycled content for several reasons, including costs and a lack of consistent quality and supply. And this is due to some shortcomings in the recycling system. So let's turn next to the topic of recycling. Back in 2018, the US and Europe had a rough patch with recycling. We had become heavily dependent on end markets in China, and the materials we were sending there were overly contaminated. China closed its doors, and overnight, 40% of the world's collected recyclables had nowhere to go. In Oregon, many communities responded by cutting back on recycling service. But this disruption also made clear a number of other problems that had been growing for years. Shortcomings in our decades-old laws that had been designed around a different set of materials, technologies, markets, and economic realities than we face today. In response, the state convened a recycling steering committee, which I co-chaired. It spent 29 months conducting a very deep study of the recycling system, examining numerous alternatives and debating options. From that process, a legislative concept was developed. It was introduced as the Plastic Pollution and Recycling Modernization Act, debated and lobbied, amended multiple times, and ultimately passed by the 2021 legislature and signed into law by Governor Brown last summer. In my last few minutes, I'm going to give you a very high-level overview of this new law. In a nutshell, the law maintains elements of Oregon's recycling systems that work well and requires changes to elements that don't. It creates a shared responsibility system, one that will be paid for primarily by the households and businesses that use the recycling system, as they currently do, but which also creates new obligations on local governments, on the facilities that sort mixed recyclables, and on many product manufacturers, including food brand owners. The Act builds on a growing trend in waste policy called Extended Producer Responsibility, or EPR. There are more than 100 existing state laws around this country covering products such as paint, medicines, electronics, and carpet. Through this act, Oregon will be the first state in the country to implement EPR for packaging, although it is already standard policy in much of Canada, Europe, and elsewhere. The act is designed to address several problems. To reduce public confusion, the new law requires the creation of one consistent statewide recycling collection list. To improve inequities in the system, the act sets up a system that better meets the needs of underserved and unserved communities and creates safeguards to prevent against irresponsible exports, such as those photos in Indonesia that I showed previously. To address unfavorable economics, the act requires producers to share responsibility with local government and ratepayers, and thus internalize a portion of costs onto their balance sheets. To address a trend in Oregon of creating more garbage and recycling less over time, the act will increase the quantity and quality of recycling as it becomes easier and more accessible across the state. It also creates incentives and programs to use fewer materials at the source. And while we currently have no guarantee of responsible recycling, the new law requires producers and recycling processors to ensure that materials collected for recycling are actually recycled and in ways that are protective of the environment and human health. At a very high level, here's how the act will work. Starting in 2025, producers of covered products, which include packaging, printed paper, and food serviceware, will join and make payments to a producer responsibility organization, or PRO. PROs will fund necessary upgrades and perform other functions that will make Oregon's recycling programs more convenient, accessible, and responsible. Producer costs will be scaled based on what materials they use and how much they sell into Oregon, with financial incentives for environmentally responsible design and material selection. Producer support will make it possible to create a new statewide recycling collection list that will make service consistent across the entire state. Local governments will maintain their current role overseeing collection and education in their communities and take on new responsibilities to expand collection service and carry out contamination reduction efforts. Materials will be directed to sorting facilities that will meet new performance standards via permit requirements or certification. These standards will require that properly prepared materials get correctly sorted and sent to the right in markets, and that contamination in the system be removed and disposed of responsibly. Both processing facilities and PROs will share in responsibility for ensuring that materials flow only to end markets that will handle the materials responsibly. The state, in consultation with a new advisory council, will oversee the system and hold producers and other parties accountable. The law does many other things. For example, there's a study on how to fix the challenges with compostable packaging. There's a truth in labeling task force that will be making recommendations to the legislature in about 2 weeks for legislation to address the tremendous damage that is caused by misleading labels and claims of recyclability. There's a number of social equity considerations in the act. Oregon will also establish accounting rules for evaluation and disclosure of life cycle environmental impacts. And the act provides a mix of incentives and mandates on brands to undertake that type of disclosure. There's a lot of information about the act on our website, and I think we have some time for questions and discussion now. Thank you very much.
Thank you so much, David. It's a very diverse subject, and we really do appreciate you taking the time to bring multiple pieces of it together. So thank you for that. For those of you who've already posted questions, thank you. And if you haven't posted questions yet, I encourage you to do so. David would love to hear from you. So the first question is from Ricardo, and Ricardo asks, are the LCAs full ones where they look at corporate social responsibility statements from producers and not just the product?
That's a great question. So the life cycle assessments that we evaluated in the attributes research, we did not conduct, actually we did conduct a couple of them, but they were largely drawn out of the literature, and they focused perhaps exclusively, I didn't read every single study, but most of them were what I would call classic ISO LCAs that were following the ISO standard for life cycle assessment for products, limited to evaluation of environmental considerations and not including social. There is a standard for social LCA. It's relatively new and not as widely adopted. but the studies that were evaluated in our research, for the most part, did not address social considerations above and beyond environmental ones.
Thank you. Ken Mosen asks, what will be the cost impact of using packaging materials that can be recycled or decompostable?
Well, we didn't evaluate that because the Act does not require the use of recyclable or compostable materials. As our research showed, recyclable and compostable materials are not necessarily better for the environment than non-recyclable or non-compostable ones. It's also a pretty difficult question to answer because it depends very much on what type of product you're talking about. I will point out here that there are certain packaging formats, especially when we're talking about the multi-material laminate films, such as are used for chip bags, for example. They're super lightweight. They're very low impact, so long as they don't go into the ocean, and very efficient at what they do, which is preserving food quality, providing an oxygen barrier, etc. Forcing producers to abandon that sort of flexible packaging just because it can't be recycled would increase costs. The packaging would be more expensive and there would be more food waste and loss as well. So both consumers and producers would suffer some cost increases if we were to mandate that all packaging be recyclable and compostable. But that is not something that Oregon has proposed. Other states have, and there is legislation being considered in at least one other state that would require all packaging to be recyclable or compostable. But that's not a discourse that's been happening up here in Oregon.
Thank you. Ricardo asks, on your slide correlating recycled material, human toxicity was atop the list. How do we leverage the fact that, for example, a water bottle with higher recycled content shed or leach more chemicals into its content, which we then consume, thus absorbing more harmful material? There's a Guardian article that he cites, recycled plastic bottles leach more chemicals into drinks, review finds.
Yes, and this is a topic that the recycling community, let me say the recycling community writ large, is only starting to become aware of. So for packaging produced in the United States, the FDA does have standards which are designed or intended to protect the public, protect public safety and health from the leaching of actually to prevent contaminants from ending up in the bottle in the first place, and then to provide a barrier so that the contaminants don't leach. But now there is this emerging evidence that there may be some leaching occurring. So there's a couple of potential solutions here. One is to make sure that the materials being collected for recycling, at least the ones going into food contact applications, are much cleaner and more pure than they are at present. For example, in this state, we have a bottle bill, and it's believed that the quality of the PET being collected through the bottle bill is much cleaner than the quality of the PET being collected through curbside programs, because there's just less opportunity for contamination. People don't, toss their not adequately rinsed pesticide container at the bottle drop. They may put their not adequately rinsed pesticide container into their recycling roll cart at their house. So it's believed that the quality of the materials collected through the bottle bill will be cleaner. There are also some additional steps that can be taken in the recycling process to screen out and remove contamination. And then finally, perhaps recycled content should not be going into applications where there is a higher risk pathway, such as food and beverage packaging and children's toys and products. And this runs contrary to 40 years of popular wisdom involving recycling, where it's believed that closed loop recycling, that is recycling a product back into the same product, is inherently better for the environment than what is pejoratively called downcycling, where you take a plastic bottle and you recycle it into something like, carpet or car upholstery or a textile or something like that. The popular wisdom in the recycling community is that closed loop recycling is environmentally preferable and this downcycling is not. But again, popular wisdom is being proven wrong. There's a number of studies that have come out recently suggesting that actually in some cases the environmental benefits of downcycling are higher. because you're displacing a higher impact virgin material, and you don't have to process the material as intensively because you don't have to clean it up to meet FDA standards. So there is recirculation, the potential for recirculation of toxics in all recycling activities. And we have to sort of weigh the trade-offs between the benefits of recycling and the burdens of recycling. Those burdens can be reduced by making sure that potentially hazardous materials don't go into products that have a higher risk potential.
Thank you. Cassie asks, aluminum has the reputation of being indefinitely recyclable without degradation and has strong incentives, the bottle bill, to be recycled. New aluminum mining is extremely environmentally degrading. Is aluminum generally a good environmental choice for packaging?
Well, it depends, because the recycling, yes, it is very recyclable, but it's not recycled at rates that it could be. There are still very significant impacts from virgin aluminum production, as you mentioned. And so if you're a producer and you're choosing between packaging something in aluminum or packaging it in, say, glass or HDPE, there are trade-offs. I've seen LCAs that show in some applications aluminum is a better choice, a lower impact choice. And I've seen LCAs that show the opposite. So just because a material is potentially infinitely recyclable, just because a material has higher levels of recycled content, does not necessarily make it a better choice over the alternative. Again, that aluminum may contain 40, 50, 60, 70% recycled content, but the remaining 30, 40, 50% has very high environmental burdens that come with it. So you have to look at the big picture and not think just about recycling considerations.
Thank you. Steve asks, have there been discussions with other states to compare the Oregon analysis with their points of view? If so, what has the feedback been?
Well, yes, we have shared the results of the Oregon. I assume you're talking about, the question is around the packaging attribute study when you said analysis. So I'll go there first. We have shared the results widely, and the response has been all over the spectrum, from on one end, people feeling that we have validated and confirmed something they had feared but had never been able to explore, and a deep sense of gratitude that we have shown a new bright light on the confusion around these popular attributes. On the other side of the spectrum, we've had some pretty sharp rebukes. And I would say these are mostly coming out as a result of cognitive dissonance. The results challenge some very deeply held beliefs. And there are people in this community, in the recycling community, who have spent the last 30 years of their careers passionately promoting recyclability and compostability as important attributes. And along comes DEQ with this very inconvenient study. And you can imagine the emotional discord and cognitive dissonance it creates for people. My experience is that people that have a more scientific background and the ability to understand the importance of and the methods of testing hypotheses generally tend to be more accepting of the study results. And the people that aren't as comfortable with that method of thinking tend to have a harder time accepting the results.
Thank you. Julia asks, what work is on the horizon around increasing the feedstock of recycled plastic to flexible packaging manufacturers?
Well, in this state, I don't know of any work that is specifically targeting increasing the availability of feedstock to flexible packaging manufacturers. Specifically, the Recycling Modernization Act will increase recovery rates and collection of certain types of plastics, and those plastics could be available to flexible packaging manufacturers. But the law is not designed to devote those feedstocks to flexible packaging manufacturers. So there will be more resin collected, there will be more resin processed, it'll be higher quality, it will be out there in the market available for end users to purchase, but it's not earmarked for flexible packaging.
Thank you. Tim asks, what category of packaging material do you think is the most promising for long-term sustainability? Biodegradable, compostable, reusable, recyclable, low impact, etc.
Well, let me strike a couple off the list. I don't think biodegradable is problematic so long as we still have a lot of packaging going to landfill, because when packaging biodegrades in a landfill, it produces methane, which is a potent greenhouse gas. Biodegradable is also problematic so long as we're trying to recycle technical materials. The classic example here involves plastics. There is a class of plastics called oxodegradables, which are conventional, for example, conventional polyethylene that has a metal catalyst added at about 1% by weight. And this catalyst, when exposed to oxygen, causes the carbon bonds in the polymer to break. So the polymer breaks down into smaller and smaller sizes so that it can be consumed by microbes. If your plastic is going into an oxygen-rich ambient environment, that's a great thing. But if your plastic is being recycled back into another product, such as house siding or piping or clothing or decking or any other material that might be exposed to oxygen, recycling this catalyst that causes the polymer bonds to break down is a very bad thing, because it can cause the product to fail. So for these reasons, I'm not particularly keen on the biodegradable attribute. Compostable has a number of challenges that could be overcome with adequate financial support for the compost industry, but that support is going to be a long time coming. There are a lot of challenges that the acceptance of compostable materials poses to the composting industry. Some of the challenges are purely practical, they're technical, they're economic. For example, if flexible packaging were to be made compostable and we started directing flexible packaging to compost facilities, there would be a lot of lookalike materials that are not compostable. And so the compost materials are potentially inundated with materials that don't compost, that are contamination. And then the compostable flexibles could compost, but compost facilities are going to have to change their operations in order to manage this new feedstock. And they may have to move their operations indoors, because until those materials are adequately shredded and ground up and contained, compost facilities are outside. You know, wind and windblown litter is a very serious issue, potential issue at compost facilities. There's some other issues with compostable packaging I won't go into, but again, that's one that is challenging. I think in the long run, in the long game, the attribute that might be the most important would be bio-based, simply because a economy that is dependent on the extraction of fossil resources is fundamentally not sustainable. The challenge with bio-based, however, as our graph showed, is that certain bio-based materials have very significant impacts because of the impacts of producing the agricultural commodities, farm level impacts, and then the impacts of converting those materials through industrial processes into a form that can be used by industry to produce packaging. So that, I think, has the greatest long-term potential in theory, but there's a tremendous amount of work that needs to be done to make bio-based production low impact, because again, as our graph showed, it is not necessarily low impact. I think I'll stop there. That was a pretty long answer. Thank you.
Thank you. Mandy asks, will the program changes work with the recycling collection companies to standardize communication to residents or directly to the household recycler?
Yes, there will be standardized communication. It will still be customized by the communities. The cities and their franchise haulers all want to have their name, their brand, their identity. That's fine. But there will be standardized materials that they can use, and the acceptance list will be consistent statewide. So if you live in live in Portland and you go to school in Corvallis and you go to visit your, your aunt who lives in Ashland, and then you go off to some festival in Bend, in the future, you should be able to recycle all the same materials in those communities.
Anne asks, is Oregon looking at collapsible plastic bags or glass containers for milk similar to the Canadian system to replace the large gallon milk containers we see in the market today?
Well, that's a great question. That is not a role that the state of Oregon plays. Would we encourage it if a dairy wanted to go in the direction of flexible, collapsible packaging for dairy? Probably. Most evaluations that I've seen of dairy packaging suggest that flexible packaging is a better choice. We have done a bit of work in some schools, public schools, through a limited grants program we have, and there are a couple of communities, Clackamas County and a couple of others, that are doing some work on their own here to bring what's called the steel cow technology into school cafeterias. The steel cow is that, it's the big metal thing with the handle. You put a glass under it and you pour yourself some milk. And some school cafeterias are exploring this as an alternative to the poly-coated paper milk carton. It's very interesting. And so that is switching the packaging of milk from a bunch of small milk cartons to this big, I don't know, it's a 5 or 7 gallon thick plastic bag. The motivation for this initially was to reduce carton waste and the use of cartons, and to replace a single-use package with a reusable package that is a glass. We did a life cycle assessment of that technology and found that the impact of the dishwasher to wash the glasses kind of obviated the benefits of producing and disposing of the milk cartons. So it was kind of a wash, sorry for that pun, but the technology had significant environmental benefits because it reduces the wasting of milk. It turns out that in school cafeterias, a lot of kids don't drink all of the milk in their carton. They drink half of the milk in their carton, and somewhere between 20 and 40% of the milk served in these cartons gets thrown out. When you give kids the option of controlling their portion size, they serve what they drink and they waste much less milk. Less milk waste in this application means less milk purchasing, and less milk purchasing means less milk production, and milk is a very high impact material, especially from a carbon perspective. And the greenhouse gas benefit of reduced milk purchasing and production is more than an order of magnitude greater than any of the benefits or impacts associated with carton avoidance or washing dishes in the dishwasher. So it's an interesting co-benefit. It's not why anyone was promoting this technology in the first place, but it turns out to be, from an environmental perspective, the most compelling justification for it.
Excellent. Well, thank you so much, David, for your really fascinating presentation. It's extremely timely, and I think just based on its complexity is really something that's important to keep sort of in the front of our minds. So thank you so much for that today.
Thank you. Appreciate the tremendous questions that people asked as well. Thank you.
Excellent. And thanks to our attendees again for making the time to join us. We really appreciate it. And also thank you for asking questions. It's very important to us to hear what's important to you.